Hey guys, today we're going to do one variable data distribution and these are the medium questions. So here our question number one is Miss Tedeschi's kindergarten class. So the frequency table details the ages in a class of 19 kindergarten students on their first day of school. Which of the following could represent the median age in months of the children in the class? So this is the age in months, and this is the frequency. So the median age in months. So median is a math vocab term, meaning if you were to put all the data numbers in increasing order, which one would be in the middle? That's what the median is. So here it already spells us out how many data there is, which is 19. There are 19 numbers given to us, so we know that the one in the middle would be 10. The 10th number would be the one directly in the middle, because there would be 9 to each side. So in this case, all you have to do is, it's already given to us in increasing number, so we just have to see which data number set, meaning which one of these has the 10th number. So you just have to add until you get 10. So 4 plus 6 is 10. So we right away we already know it's in between 62 and 63. But let me show you, if let's say you were to do it from the other side. So 3 plus 3 is 6, plus 3 is 9. So the 10th number is again in this data set. So we know that the age in months of the median would be either 62 or between 62 and 63. So the only answer choice that is between 62 and 63 is A, 63. Number 2, Mr. Shamir graded the test of all his students. Since every student missed the same question, he decided to add 5 points to each student's score. How does this affect the mean and median of the test scores? So let's do the easiest one first, median. So median, there are still the same amount of data, but it's just each one is added by 5. So the number of data will stay the same, but the value of the data will change. So that might sound a little confusing, so I'll explain what that means. So let's say the data was, we have a data that is 0, 1, 2, 3, 4, and let's do 0, 1, 2, 3, and 4. Okay, so in this case, the median would be 2, because that is in the center. And then if you add by 5 for each one, the median will stay in the same place, meaning it will stay right here in the middle. It's just all the data is added by 5. So the median will just be added by 5. So in this case, from 2 to 7, I mean. So it will be added by 5. So that's the same in our case of the test scores. It's added by 5. So we know that the median will be added by 5. For the mean, in this case, so let's say our mean was originally x, okay? Or actually not our mean. The data, if you add all the data together, the sum of all the data, let's say, is x. So x is the sum. Of the original data. So x plus, and then you're adding 5 for each one. Let's say we have 5 test scores. So x plus, we have 25, because it's for each of the test scores, divided by 5. So x plus 25 divided by 5 is the second number, and the other one would be x over 5. So x over 5 would be the mean in this case. So the mean, or the original mean rather, the original mean was x over 5. Let's set another variable. X over 5 is equal to y, let's say. So here, for our new mean, x plus 25 over 5, So x over 5 would be, you could also write this as x over 5 plus 25 over 5, which 25 over 5 can just be written as 5. Correct? So, x over 5, you can replace x over 5 for y, because we made a y. And our original is also equal to y. So, we know that original plus 5 is our new mean. So, it's also added by 5. So, our mean is added by 5. So, the mean and the median both increase by 5, which is answer choice A. Number 3, Mrs. Carey had her class take a quiz. She calculated that the mean score was 81, the median score was 78, the mode score was 85, and the range was 35. She decided to give every student 5 extra points. Which statement is true? So, the mean will definitely increase. So, because mean always, if you increase the value of all the numbers, you're still dividing by the same amount of data that was collected, your mean will increase no matter what. So let's write mean increases. Next, median. The median was 78. So if you add 5 extra points, as I mentioned in our previous problem, it will stay in the same data number, but the value will increase by 5. So 78 will turn into 83. So median increases to 83. The mode score was 85. So if you add 5 extra points, now the mode, it's still the same amount of repeated data will be 80, would be that 85 thing, but the 85 actually, the value of the data turns from 85 to 90. So the 90 will now be the most repeated number. So mode changes to 90. Or let's write increases instead. The mode increases to 90. Lastly, the range was 35. Now, range is the difference between the greatest number and the lowest number. So, since both the greatest and the lowest will be added by 5, so let's say the greatest, for example, let's say x was the greatest and y was the lowest. So, x minus y would be the original range, equals r, let's say. But now we are changing it to x plus 5 minus y plus 5. Correct? So, first of all, you could think about it logically. If you're adding both of them by 5, the difference will be the same. But let's see algebraically. So, x plus 5 minus y plus 5. So, this changes into x plus 5 minus y minus 5. So, x n equals something, so we don't know what it equals. So x plus 5, so plus 5 and minus 5 will cross out. So we are left with x minus y. And we know x minus y is r. So x minus y equals r. So we are left with the same answer, r and r. So the range will stay the same. The range will stay. So which statement is true? The mean will stay at 81. So we already know it increases, so that is incorrect. The range will increase to 40. The range will not even increase, so that's completely incorrect. The mode is the only measure that will change. So that is wrong, because we already saw 3 measures that will change. So that's incorrect. The median will increase to 83. That's exactly what we wrote down. So our answer is D. Question number 4. The dot plot shows the weights in kilograms of the players on the Chinese Olympic men's ice hockey team in 2022. If the lightest player and the heaviest player are removed from the team, what will be the effect on the standard deviation? So standard deviation is how much it is spread out. So here our standard deviation is pretty spread out. So you don't even have to do any calculations here. Once you take out these two data numbers, we are left with a more squared standard deviation. No need for any calculations. So our standard deviation will decrease, B. Number 5, our last question for the medium one variable data distributions. The table lists the weights of 8 cats treated at a veterinary clinic. According to the table, what is the median weight in pounds of these cats? So median, once again, is if you put it into increasing order. So here we have increasing order would be 7.8, then 8.2, then 9.5, then 9.7, followed by 10.2, 11.4, 12.1, and 14.3. So here is all our data. So we could see that we have 8 data numbers. We have 8 collected data. So our middle would be the mean of the middle two. So our mean of the middle two, so if we look from this side, there's 3, and this side there's 3, so the 2 in the middle would be 9.7 and 10.2. So you would simply just get the mean of that. So 9.7 plus 10.2 is 19.9. Then you would divide that by 2, which is 9.95. So our answer here is 9.95.